we run into the same thing with logarithms, because again, all a logarithm is a what? Or is an exponent. So, if we've got the log base b of m plus the log base b of n, what will that equal to? Well, let's think about it in terms of this. Let's go and let's say that we have the log base b, not base b, let's do a different thing. Let's say we have the log base 3 of 9 plus the log, sorry, I'm going through puberty, I guess, because my voice is cracking. Log base 3 of 27. I can't believe I said that and I'm recording this lesson. But anyway, what do we get when we do that arithmetic? Well, what is the log base 3 of 9? In other words, 3 to what power is 9? 2. So we would get 2 here. And then what is the log base 3 of 27? And 2 plus 3 is 5. All right. Now let's take this a different way. Do some cheat work over here. Okay, so now let's say we have the log base 3 of 243. And we want to know what that is equal to. Well, 3 to what power? And you can use your calculator if you want to. 3 times 3 times 3 and do it till you get to 243. 5, right? Okay. Now, what is 243? Well, 243 is, if you do the arithmetic, it's 9 times 27. And right over here, did we not just figure out the log base 3 of 9 times the log base plus the log base 3 of 27? So the log base b of m plus the log base b of n is equal to the log base b of m times n. For the very reason I just put on the board there. The log base b of m plus the log base b of n does not equal to the log base b of m plus n. That is the biggest mistake you can make on this. People who make that mistake right there wind up being the same people who have babies that are born naked. So anyway, now, are we good here? Okay. So that's how we do a product. Well, we're going to do similar with the quotient rule here, but guess what's going to be different about the quotient rule portion of this? It's going to be minus, right? So this is one property. The next property is that if we have the log base b of m minus the log base b of n, that would equal to, what do you think?
Log base b
of m over n. Are we okay here?
Mm-hmm.
All right, so that's another big property that will come in handy in solving some of these problems out. there's a power rule, and the power rule is gonna probably make more sense than any of them. It says the log base b of m raised to the p power is the same thing as p times the log base b of m. In other words, you take that exponent and you pull it out to the front, and that's what you get. So, I'm gonna use this as my example here. We know the answer is 3, right? So we have the log base 3 of 27 here. And the log base 3 of 27, well, what is 27? Well, it's the same thing as 3 raised to the third power. So, according to this, what I can do is I can pull this 3 to the front and make it 3 times the log base 3 of 3. Wow. I just can't keep my voice right now. So, what is the log base 3 of 3? Starts with a W. 1, very good. So, we get 3 times 1, which is 3. And that's what we said over here earlier, right? That the log base 3 of 27 was 3. So it's just a different way of looking at it. Are we good to keep going? All right. Next, we're going to look at condensing logarithms and expanding logarithms, which is what we've pretty much done with these properties so far. This is expanded, this is condensed. This is expanded, this is condensed. So I think it's easy to show condensing first and then expanding afterwards, but it's up to you. Anyway. So let's say that we have the log base b of m squared x over y. The log base b of m squared x over y. Well, wherever I have multiplication, that is the same thing as addition, right?
Mm-hmm.
So I'm going to expand it out. What's wrong? I thought I heard someone say something. Okay. The log base b of m squared plus the log base b of x, and then minus the log base b of y. Now, they actually don't want you to leave it like that. What do you think the other thing they want you to do here is?
Condense the bases.
Say that again?
Condense bases in log.
Well, we're not going to condense because this is an expansion problem, but the other thing they want you to do here, and this is just kind of ticky, but they won't give you credit for it, you just pull the 2 to the front. So it's 2 times the log base b of m plus the log base b of x minus the log base b of y. So all it is just pulling the power to the front. I don't know how one's considered more expanded than the other, but that's what they're going to want you to do on the computer. And I mean, it's good to know, so it doesn't hurt to do it. Now, there is one little catch to these problems, and I'm gonna go ahead and show it to you so you don't mess it up. But I'm gonna make it m squared over x, y. And I'm gonna break this down twice to make it a little bit easier to see. And this doesn't look a whole lot different from this problem either, does it? But the difference in it is how we handle the multiplication in this part. So this is the same thing as the log base b of m squared. All right, now, this right here is all being divided, correct?
Mm-hmm.
So I subtract from it the log base b of x, y. Now, I'm not done yet. I'm not done yet. But that's what's all being divided. Now, this minus goes with everything right here. So my next step is I'm going to go ahead and pull the 2 to the front. So it's 2 times the log base b of m. But it's going to be minus, and then I'm going to insert in parentheses the log base b of x plus the log base b of y. So I've got to have that multiplication because the entire multiplication was in the denominator. That entire multiplication has to be subtracted. So this is where the catch is when you do the problem. Now you have this minus associated with both of them, so I'm going to distribute it in to this parenthesis here. So it becomes 2 times the log base b of m minus the log base b of x minus the log base b of y. Is there a question about that? Okay. Kate, you good? You don't have any famous quotes for me yet today? Are we good?
Mm-hmm.
Okay. Alina, are you good now?
I have a question.
Okay.
Earlier you said that the log base had to be multiplied, like the m and n had to be multiplied, and that the answer could not have m plus n. But then I see log base x plus log base y. It's not.
You're talking about right here?
Yeah.
Okay. Do you understand this step here? This is a division problem, right?
Yes.
So because this was divided, I subtracted the numerator portion from the denominator portion.
Subtract. Yeah. Subtract m squared. Yeah.
Yeah, okay. Now, at this point right here, I've still got a multiplication of two things, right? So how do I deal with multiplication?
Repeat.
I add, right? So all I did is I took what was right here, I left this minus alone, and I just handled the log base b of x times the log base b of x times y, and I made it the log base b of x plus the log base b of y. Well, now I have this minus out here, so it distributes in.
Oh, okay.
Now, let me say one other thing with this. I would hope, my hope for y'all is that you could go straight from here to here without doing any steps. If you can, that's great. If you can't, it's not the end of the world. But really what's happening in the grand scheme of things is both x and y are being divided, correct? So if both x and y are being divided, then they should both be associated with a minus sign. And that's the reason they're both associated with the minus sign there. Because they both have to do with the division portion, or the denominator portion, I should say. Does that help? All right. So that is expanding a logarithm. Let's look at condensing a logarithm. And again, I'm gonna do this a little bit out of order. I'm gonna say the log base b of x minus the log base b of y plus the log base b of z. Okay, now, thinking about what I said right here. Anything in the numerator I associate with a plus. Anything in the denominator I associate with a minus. So I'm going to do this all in one step. There is no sign out here, so it's assumed to be positive or negative. Which one? Positive, okay. So x is associated with a positive, z is associated with a positive. So these two right here are going to go in the numerator, and that's going to go into the denominator. So this is going to condense to become the log base b of xz over y. Okay, so I've got 4 different problems up there. I'm defining the log base b of 5 to be a, and I'm defining the log base b of 6 to be capital B. So these two b's are in no way related to each other. Because if they were, if I had the log base b of b, it would be 1. Now, let's talk about A. A says that we have the log base B of 5/6. What do we know that to be the same thing as if we expand it?
Log B of,
Log base B, so make sure
or
you say.
log, yeah, log base B 5 minus log base B of 6.
All right, what is the log base B of 5?
A.
A. And what's the log base B of 6?
B.
B. So A minus B is my answer here. Everybody okay here? Okay? B, the log base B of 30. Okay, well that's not 5 and it's not 6 either, but what do we know about 30? It's 5 times 6, right? Okay, so I can turn this into the log base B of 5 times 6, which would be the log base B of 5 plus the log base B of 6. So what do I get as my answer here?
A plus B.
A plus B. Okay. C. I have the log base B of 5/36. Well, that's the log base B of 5 minus the log base B of 36. Now, I know what the log base B of 5 is, right? It's A. But what about this log base B of 36? How can I handle it?
6
Hmm?
times 6.
6 times 6,
B.
or we could just say
Third.
6 squared, right? Okay, so it's minus the log base B of 6 squared, which is 2 times the log base B of 6, right? Which would be
2B.
2B. And you would have gotten the same thing if you'd done 6 times 6 there as well. If you'd done 6 times 6 there, you would just had minus B and minus B. Well, what's minus B with minus B? It's minus 2B. So that's funny you said that, because I didn't even, when I was making up that problem, I didn't even think about doing it that way, but it gets you the same answer. And that's, again, that's what I love about math. You can, two people will see a problem totally different, and as long as your arithmetic's correct, you're gonna get the same answer. And that, the further along you go in math, the more that happens. It's just neat. And I see that all the time in calculus. In fact, Samantha Massey this morning showed me an easier way to work a problem than what I did. So, all right, now on to the log base B of the cube root of 5. Well, what do we know about the cube root of 5?
5A.
Say that again.
5A.
How do we rewrite the cube root of anything as an exponent?
Negative.
No, that'd be if it was 1/5.
1/3.
It's 1/3. So this becomes the log base B of 5 to the 1/3 power, which is 1/3 of the log base B of 5. And guess what the log base B of 5 is? A. So we get 1/3. A is our solution. So, that pretty much covers everything that we're going to do today. So, y'all can go ahead and start on the assignment again. Got 4 assignments left. Let's make sure we score perfect on all of those, and then perfect on the quizzes, and get that 20% of your grade up there, and then we'll roll from there.